Antarctica does seem a long way away, but actually what happens around Antarctica is translated to change globally. Melting ice means we raise sea levels around the world. These impacts that seem a long way away are actually going to be impacting right to the shoreline of Australia. At the moment, ice sheets and ice shelves, both around Antarctica and also over Greenland, are missing from our climate projections. This is a big issue because that ice sheet melt contributes to global sea level rise, so we need to factor that in when we build our sea level rise projections. Here at ACEAS, we've incorporated that ice sheet and ice shelf melt into future projections by building a very high-resolution ocean model that captures dense water formation sites. The very first IPCC projections didn't include Antarctic ice melt. It was considered too hard a problem to incorporate. That missing piece of the sea level puzzle is so important for our policymakers. You need to consider Antarctica, how it's changing, and how to include it properly in the models.
Globally, the ocean takes up around a third of the extra carbon that we've been emitting, and around 40% of that is absorbed in the Southern Ocean. Most global climate models don't resolve ice shelf cavities, so this is the region of the ocean underneath the ice shelves. And this means that the models aren't resolving the actual process of melt. So one thing that we've done through ACEAS that's really revolutionised Australian ocean modelling is to be able to resolve these ice shelf cavities by pushing the boundaries of the resolution of the models. We've developed very high resolution, down to 1 kilometre grid size around Antarctica. All of our ocean model simulations are run on NCI. That's really what's enabled us to run our models at such high resolution. Collaboration is essential, especially for Antarctic science. We work really closely with biologists and biogeochemists. My work wouldn't be able to be done without this type of collaboration, and ACEAS has been fantastic for bringing together all of those different people into the same room.
Our main focus is on trying to understand how marine ecosystems respond to environmental change and how we can best manage marine fisheries. We know the decisions that we make now will profoundly affect ecosystems into the future. One of the key challenges in modeling fisheries, we don't have perfect knowledge of whole ecosystems. So ACEAS has helped support the inclusion of Southern Ocean researchers into this wider global network, which is the Fisheries Marine Ecosystem Model Intercomparison Project, also known as FishMIP. We have over 100 ecosystem modelers involved in this network around the world. Our results are a part of the National Climate Risk Assessment, so it can help improve climate adaptation strategies and fisheries management in Australia by providing broad-scale metrics of risk, also to help build capacity of doing marine ecosystem modeling in this region in a way that takes into account climate change. What gives me hope is that we as a team can use our skills as marine ecosystem modelers to help shape what could be more sustainable future pathways.
Krill are fundamental within a lot of regional Southern Ocean ecosystems, but they're incredibly important as prey that feeds and sustains huge populations. They're also a critical grazer on phytoplankton. Phytoplankton will be sitting at the surface of the ocean and they'll be taking in all the carbon dioxide in the atmosphere, and the krill will incorporate all of that carbon in their bodies. It's an incredibly important process in the carbon cycle, but also in understanding and mitigating climate change. One really significant piece of work that we've been working on here at ACEAS and in collaboration with international researchers has been the model called krillpidum. What this model can really do is help us understand the population in a much better light. That information is really fundamental groundwork for understanding then how we make decisions around allocating catch limits, how we spread catch so that we can minimize impacts on localized areas. If we at ACEAS can deliver that science to Australian decision makers, they can then take that science and deliver it to the rest of the world